Okay, here are the results in a dot plot set of simulations, where each point represents a simulation. So you can see right there in the middle, 0, that's going to be the null value. That's always going to be the center of the graph and basically represents what random chance, what we'd expect from random chance. The point estimate can be anywhere along that horizontal axis, from the negative or positive side, anywhere. In our case, this study, we had a point estimate of 0.2, so that's our observed difference. And then the proportion of these dots that are equal or more extreme than the point estimate is what's called the p-value. And that's going to be the number that decides whether we go with the null hypothesis or the alternative. Since there are so many points, it is more convenient to summarize the results in a histogram, where the height of the histogram, each histogram bar, represents the fraction of observations in that group. So, if there was no treatment effect, then we would only observe a difference in at least 20%, about 0.6% at a time. That would be the heights of this bar and this bar. So the heights of these two bars come out to be about 0.6, or about once every 150 times. That's really rare. So since that number was so small, once in 150 or 0.6%, we will conclude the data provides strong evidence that there is a treatment effect. Reminding students before purchase that they could instead spend the money later on something else lowers the chance that they will continue with the purchase. Now, notice I made a causal statement here because we had random assignment. This was an experiment. Okay. The null distribution below represents 500 simulations of the opportunity cost study. Use the graph to estimate the p-value. So what I want to do is I go where the point estimate is, 0.2, and then I see there's one bar to the right of it. So the height of that bar is right there at 5 out of 500, so that's about 1%. So we locate the point estimate along the horizontal axis, add up the heights of the bars equal or more extreme than the point estimate, so that 5 there, divide by the total number of simulations, in this case 500. So the p-value is going to be 5 out of 500, or 0.01. So based on these simulations, the probability we could have matched up my original study was about 1%. So only about 1% of the simulations match up with our actual study. That means our study is probably not due to random chance alone. It's very unlikely that random chance could have explained my sample, so there's probably some other effect.